In 2.7, we are looking at the transitive and substitution properties. So allow me to please talk for a moment about canines. There are different types of canines: German Shepherds, Chihuahuas, Poodles, even wolves. So similarly, we have substitution, and a very specific type of substitution is the transitive property. If something's transitive and you call it substitution after this chapter, that's okay. For this chapter, you need to differentiate what's specifically transitive and what's substitution. If at any time you call substitution transitive, that could be wrong, because remember, the converse is not always true. For example, all German Shepherds are canines, but not all canines are German Shepherds. All transitive statements are substitution, but not all substitution statements are transitive. So let's take a very close look at what the differences are. Here we have, suppose that angle A is congruent to angle B, and angle A is congruent to angle C. We're being asked, is angle B congruent to angle C, and if so, how? Well, if we line up the two angle B's, we see that they kind of cross out like our chains of reasoning, and we can infer then that angle A is congruent to angle C. Notice, however, that only congruence is involved. That is the transitive property. It works with segments or with angles. The substitution property would involve another operation or a measure. So if we said angle A is equal to angle B and angle B is equal to angle C, then we would say angle A is equal to angle C by substitution, because we're inferring that there are measures here. So you use the transitive property in proof when everything involves congruent things. If something is not congruent in what you're trying to put together, then it's substitution. Let's look at some examples. FG is congruent to KJ, and GH is congruent to KJ. They're all congruent and to the same, so we can say that FG is congruent to GH by the transitive property. And then, if a segment is divided into two congruent segments, the line that divides them is a segment bisector. Given angle 1 plus angle 2 is 90 degrees and angle 1 is congruent to angle 3, notice here not everything is congruent. So what we're doing is actually replacing that angle 1 with angle 3. So this would be substitution. If EU is congruent to ID and CL is congruent to ID, then EU would be congruent to CL by the transitive property. And UC is congruent to itself by the reflexive property. So EC, remember I have to mark the bracket, would be congruent to UL by adding the same segment to congruent segments, and that would result in congruent segments. So if angle X is congruent to angle Y and angle X is congruent to angle Z, then angle Y would be congruent to angle Z by the transitive property. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.